This is Natural Selection Lesson 1.4, Activity 3. Scientists create models to communicate ideas about how things work to other people. Some models are like physical models, like a globe or a model of a cell, and then other models are computer programs, like a computer model that predicts weather or the natural selection simulation. And some models can be visual representations like a food web or a diagram of the water cycle. In this unit, you'll be using a special tool called a modeling tool to make visual models to show that you're thinking about why populations change over time. So we can see a model here. This is for fur and temperature of the Australopes for population A. And so the goal is to show how and why population A changed after the environment changed from warm to cold. So you can see that there are two histograms here that represent the same population at two different points in time. So this is the starting population. This is a histogram for the starting population. And then after a later point in time, this is a histogram for the population after 50 generations. So again, you can see there's a timeline down here to show that this is earlier in time and then this is later in time. There are labels below each histogram that describes aspects of the environment and whether the environment is changing. So at the starting population, we can see the environment is changing from warm to cold, and then now the environment is just cold. So this one's changing, and then after some time, the environment is just cold. And then at the bottom here, there is a trait label. This is a legend that shows symbols and what those symbols mean. So a plus S means more likely to survive, and a minus S means less likely to survive. So you are going to be adding pluses, plus S's and minus S's, and the starting population histogram, we can see that the environment is changing from warm to cold, just like in the previous sim activity. The Australopes that were more likely to survive in that instance were the ones with more fur. And the Australopes that were less likely to survive in the cold environment were with low fur. So the adaptive trait, the one that allowed them to survive, was more fur, and the non-adaptive trait was the that didn't allow them to survive was low fur. So we are going to see how this model would be completed based on what we saw from the sim. And what we saw in the sim, again, was that the non-adaptive trait of low fur, they were less likely to survive. They wouldn't survive. And so what we've done is we've written a minus S, minus S, minus S above the bars for traits of low fur 1, 2, and 3. So minus S is less likely to survive. So these three were less likely to survive. And then we added a plus S plus S plus S on 5, 6, and 7, where there's traits of more fur. These were more likely to survive. So how do we, once we add the minus S's over the ones we think that are less likely to survive and the plus S's over the ones we think are more likely to survive, then we need to reflect that in our distribution after the environment is now cold. So this is one way to complete the model. We would show that there's more individuals. There's a higher distribution in the Australopes with more fur, and then there's still a lot, but a little bit less. And so you can see that as more fur, as a trait of more fur, we have a higher distribution. So in the sim and the warm-up, we observed that the distribution of traits changed over time. So this example modeled the change we saw in the sim. This is exactly what we would have seen in the sim. And so this is what we're modeling here. So we just learned that traits for higher fur levels are adaptive traits in a cold environment because they help australopes survive in cold environments. Lower fur level traits make it difficult to survive in a cold environment, and so those are non-adaptive. You're going to continue to investigate what causes the distribution of traits in a population to change as you create another model. So you are going to be doing population, so fur and temperature, population B. So at this point, this is a modeling tool where you would either, your teacher would be handing you a piece of paper in class, or you'd be downloading something to Notability. So that's what you're going to be doing, is you're going to have to download this modeling tool into Notability. So to do that, you're just going to go to Canvas and you'll go to NS lesson 1.4 activity 3, which is probably where you already are. And as you can see, it says watch the video and follow along with the instructions to complete this in Amplify, and when prompted, download this into Notability. So you're going to click on this and you're going to send it to Notability, and then when you're done, you turn it back into Canvas. I always create the Notability note title, this, to be the same title as this assignment. So you can see here, you just turn it right back into here. So whatever the title is in Notability, that is the title that of the assignment you'll turn it into in Canvas. So I do that to make it easy. All right, so you're going to download this to Notability. It should look like this. So what you're going to do is you're going to predict how and why population B will change after the environment changes from warm to cold. So just like A, most populations, most of the australopes in population B have low fur level traits. There is much less variation than population A. There's only 2 different traits, so it's a low variation. And both population A and B are experiencing an environment changing from warm to cold. So you're just making a prediction. We don't know yet how the distribution of traits in population B is going to change as a result of the environment becoming cold. So you're going to make a visual model by doing what you saw in A, where we added the plus S's and the minus S's, and then we added where we thought the distribution would be after. So same thing here, plus S minus S, you're going to put over these two, and then you're going to show what you think happens over here. Again, this is just a prediction. In the next activity, you're going to be using the sim to see what would actually happen in this scenario. So once you complete this, by adding your S's and then doing anything over here if you want, turn it in to Canvas, NS lesson 1.4 activity 3. And that's the end of the video.